Hello everyone, welcome to the Cumulative Review homework. This is 10 questions that'll definitely help you prepare for class tomorrow. So let's get started, shall we? The first example is an inequality and it's an AND problem. So remember, in the end, we are looking for overlap when we graph both on the same number line. So we want to graph these separately. So if we solve the first inequality, the first thing we want to do is add 4 to both sides. So we get negative 3x is greater than or equal to negative 9. Then, if we divide by negative 3, don't forget if we divide by a negative, the inequality must flip. So it becomes less than or equal to positive 3. And this next one, it is 2/3 times x. So if you're doing 2/3 times x, what you're technically doing is dividing both sides by 2/3. As we've talked about, the faster way to move that would be multiplying by the reciprocal. And the number we're moving this time is positive, so the inequality does not flip, but this becomes negative 24 over 2. This is really 8 over 1, so x is really less than negative 12. So my answer algebraically is x is less than or equal to 3 and x is less than 12. So on a number line, I'm going to put the 0 over here, 3 here, and negative 12 down here, just for spacing purposes. So if I graph the first one, x is less than or equal to 3. That is a closed dot towards the negatives. If I graph x is less than negative 12, that's an open dot also towards the negatives. So if you look at the red and the blue, the place where the red and the blue start to overlap is here at negative 12, and then all the way down towards negative infinity. So my answer graphically is just in the green. The next problem, solve the equation for x. So if I recopy it over here, 4x minus 5y over b equals 7c, we want to get x alone. And so if we look at this equation, I notice that the b is usually the problem, so I'm going to get rid of it. I'm going to multiply both sides by b, so I'd get 4x minus 5y equals 7cb. All of these are multiplying, so I'm going to go ahead and change the order, because multiplying order doesn't matter, and I'm going to make it alphabetical. My next move to get x alone is to move the 5y, and so I'm going to add 5y to both sides. 4x equals 7bc plus 5y. Remember, we have to keep these separate because these are not like terms. The last thing I need to do to get x alone is divide both sides by 4. So your answer could look like 7bc plus 5y all over 4. This is a perfectly reasonable answer. If you'd prefer, you could divide both of these by 4 separately and get 7bc over 4 plus 5y over 4. Both of these answers are good, and both will be accepted. The next one, solve this equation. We are solving an absolute value equation, so my goal is always to get the bars alone. So if I want to do that, I notice that this negative 7 is not attached to the bars, so I'm going to move it away first by adding it. So we have 3 times the absolute value of 2x plus 4 is less than or equal to 18. We can't figure out what this means yet, again, until the bars are alone. So we need to divide the 3 out. 2x plus 4, absolute value, is less than or equal to 6. So at this point, we have the phrase that distance is related to a positive. And we know distance is always positive, so we can keep going this time. And you may recall that we have 2 different options here, because if this number is originally positive in the bars, it's going to come out positive. So we have 2x plus 4 is less than or equal to 6 is one option. But it is also possible that this inside the bars could originally be negative. So we could say that 2x plus 4 is related to a negative originally. So if we put a negative 6 over here, what we've done is change it from a positive to a negative, so my inequality must flip also to represent that change. And so now, like the first example, we're going to have to solve these separately, but we don't know this time what is in the middle. So we need to look back here and recognize that this is a less than problem. So I'm going to put the word and in the middle. And so let me solve away. This first one, if I subtract 4, I would get 2x is less than or equal to 2. So x is less than or equal to 1. And subtract 4 here. 2x is greater than or equal to negative 10. So x is greater than or equal to negative 5. If I go up to the top and graph this situation, we have 0, negative 5 is going to be down here, and 1 is going to be right next to it. So x is less than or equal to 1 is closed dot towards the negatives. X is greater than or equal to negative 5 is closed dot towards the positives. So if I wanted to graph my and, again, overlap answer, that would look like the red and the blue coming together would only cross between negative 5 and 1. So my graphical answer is just the blue. So please remember, whenever you see absolute value bars, because the number in here could either be positive or negative, that's why you have two options down here. The cost of a North Face jacket is $120. Luckily, you found a coupon for a discount of $30, but because you live in Illinois, there's a sales tax of 7%. What is the total cost of the jacket after your discount and paying the tax? Well, I'm going to show you again two methods we did in class recently. If your total jacket cost is $120, the first thing we want to worry about is my discount. And my discount is 30%. So we could multiply by 30% because remember you're finding the discount of, and of is always multiply. If I take 120 and multiply that by 0.3, that would be $36. So my discount is $36, and discount is a good thing. So I'd take my 120, I would subtract off $36, and I'd be left with $84 so far. However, we have to deal, unfortunately, with the sales tax of 7%. And remember, the 0.3 came from the 30%. You just move the decimal over twice. So now my new total is $84. And 7% as a decimal is 0.07. So we need to find the tax of what's left. So 84 times 0.07 gets me $5.88. This represents my tax, as did this represented my discount number. So this time, tax is a bad thing. So I'm going to take my new total, 84, I'm going to add $5.88, and I am going to get $89.88. So that is my total cost with the discount and the sales tax. Now again, if you're interested, if you want a faster way to do this problem, you know that the jacket originally cost $120. You had a discount of 30%, which means you actually paid 70%. So you could multiply this by 70%, or 0.70 is actually what you're paying. And in class we talked about that you're paying 100% of the jacket plus 7% of tax, which is really paying 107%, which as a decimal is 1.07. So if you multiplied 120 times 0.7 times 1.07, this represents what you're actually paying, not what you're taking off, and that would also be $89.88. Find the equations of the following lines. Well, this one is a perfectly horizontal line that goes through the y-axis and hits at -1. So that means your equation would just be y equals -1, because no matter what, y is always -1 on every point on this line. B, however, is a vertical line, and B looks like it hits the x-axis at 4. So my equation this time would be x equals 4, because again, all the way up and down this line, x is always 4 and never changes, and it hits the x-axis right there. So these are the special cases of lines. Please keep them in mind. Number 6, 5 less than 3 times a number is at most 25. Write an inequality for the situation and then solve. So if we break this down, 5 less than, that to me could either be an inequality sign, but more likely subtraction. So 5 less than 3 times a number. 3 times a number can be represented just by 3 times x. If we're talking about 5 less than 3 times, that means that the 3 times the number comes first. So if we're doing 5 less than that, it would be 3x minus 5. And all of this is at most 25. At most means you can be, this is the biggest number you could possibly have. So it would be less than or equal to 25. So your inequality is 3x minus 5 is less than or equal to 25. But my actual answer to solve would then be 3x is less than or equal to 30. So x must be less than or equal to 10. The reason this one is on this paper is we've noticed, Mr. Foster and I have noticed, that this situation, 5 less than, is something that a lot of you have missed on past assessments. So please just keep this in mind as we keep going. Number 7 asks you to solve this equation. So if I was to do so, looks like we have like terms on both sides and the distributive property. Order of operations tells me that I must multiply or worry about the parentheses first. So if I do that, that would be negative 8x plus 28 plus 10x equals 5x. We are distributing a negative 3, so it will be minus 3x, negative times negative, positive 12. Let's clean this up a little bit and combine like terms on this side. So this side would become negative 8 plus 10, 2x plus 28 equals, clean up this side, 5 minus x is also 2x plus 12. Sorry about all the interruptions. My computer seems to be freaking out. If I want to continue solving this, what I did in class earlier in the year was consistently move the variables first. But if I do so, it looks like these cross out, and so do these. So I'm left with the statement 28 equals 12. And you and I both know that this statement does not make sense at all. So we've said that this statement's absolutely false, which means that the answer to number 7 is no solution. So you could write out the words, or you could write the null set symbol. Number 8 says evaluate using the order of operations. And the trick we've been using is the PEMDAS, parentheses, exponents, multiplication, division on the same level, addition, subtraction on the same level. So I want to evaluate 2x squared, but first I want to plug in negative 3 for x. Now I use parentheses so that I can clearly see that the negative is within my parentheses, and it helps to see that if I'm deciding do I multiply first or do I square first, I remember exponents always come first. It's very tempting to make that negative 6, but we can't. We need to say what is negative 3 times negative 3 squared first, so that would be 9, then multiplied by 2, so my answer would be 18. Number 9, you have a fraction equaling a fraction. And so when that's true, that means that your diagonals themselves are also equal. So this is when we cross multiply. So we would have 2 times 2x plus 3 as a diagonal is the same as 6 times x minus 6. So I've created an equation for myself to distribute. 4x plus 6 equals 6x minus 36. And if I wanted to solve this, I again am going to move my variables first. Negative 2x plus 6 equals negative 36. Subtract 6 to the other side. Negative 2x equals negative 42. Then if I divide by negative 2, my answer would be x equals 21. This last one, we have 7, 6 added to x. So the first thing we needed to do is subtract 7, 6 from both sides. So we have x equals negative 2/3 minus 7, 6. So this is when you need a common denominator. So let me have you pause and try this first, and the work will be here when you get back. My answer was negative 11/6 because I multiplied this first fraction by 2/2.